In this example, we're going to look at a compare contrast of linear functions versus exponential functions, and how things lay out and how we figure out how to take this equation and just put it into words. Like, what does this actually mean in everyday language? So Beth has purchased ladybugs to release into her garden to help with her aphid problem. Let L represent the number of ladybugs in the garden, and let A represent the number of aphids in the garden T months after the ladybugs are released. Describe what each of the following tells us about the number of bugs in Beth's garden. So I'm going to talk it out with you first, and then you can kind of pause, see if you can figure some out on your own too. But first of all, like just looking at these two here, L is the number of ladybugs, right? And we have 25t plus 30. So the clue is the form is y equals mx plus b form. We also just have this like constant increase of ladybugs of 25 every month, because t represents months. We know our y-intercept is 30, so that I would say Beth released 30 ladybugs. They increased by 25 per month, so that's a linear. So here's how I would write that out in words. I have Beth released 30 ladybugs. They increase in population by 25 bugs each month. Now looking at the next one, you can tell by the format too. I have an exponent that is a variable up there, so exponential. I have a coefficient and I have a base to an exponent. So this would be my initial value here. I know it's exponential because it's in the form y equals ab to the x, right? So therefore, these three dots mean therefore exponential. I know that my base, it's a rate, right? So I have a half it's the base of an exponential, right? So this would be my rate of growth or decay. Okay, so this is number of aphids here, right? So this one's going to be actually a decay because it is a half, so it's 50%. So we'll just write decay. So let's see if you can write that in just everyday words in lay terms. Pause and see if you could do that, and then I'll write out my sentence. Okay, so the sentence I wrote is there were initially 220 aphids in Beth's garden. The population of aphids is cut in half each month, or you could say decreased by 50% would be an okay thing as well. So I'd like you to try these other ones as a classwork. So pause and see what you come up with for that. I think the ones here that have the coefficients on the exponents, like this is 2t, right? So that's a little tricky. So I'm going to give you a little hint, right? So this, if this t is a month and I'm having that happen twice in a month, so think instead of each month you would say twice in the month, or every couple of weeks is really what's happening, but we'll keep it in terms of months. You could say every half month. And then this one is a third t, so it's a third of it's gonna take longer, right? So that's going to actually be happening in a different cycle. So relate that to here. See if you can figure that out. But I'll write out all the answers for you to check back with. Okay, so here are my sentences here. We can see that this first one is exponential, 25 times 0.15 to the t. Beth initially released 25 ladybugs. they increased by 50% because that's at 0.5, 100% plus the 50%. So we're always kind of thinking of the base normally would be 100%, and then if we increase, we're adding on. If we decrease, we're subtracting off that 100%. So just keep that in mind. And this next one is the aphid one. It is linear. So she had 360 aphids. They decreased just by 20 aphids. So it wasn't a rate there. It wasn't a percent increase or decrease. So that also shows how you word it with just a linear, right? It's just the number of aphids per month. The next one is exponential ladybugs. So this one, Beth released 60 ladybugs. They increased by 12%. Because that's that 0.2 increase onto the 100%. And it happened 2 times every month. So twice a month. And then the next one would be exponent or exponential. She had 850 aphids. They decreased by 40% because remember, be careful not to fall into the trap of putting 60% there because it's 100% minus whatever my decrease is goes in for the base. And then this is number of months per every 3 months, right? So it's when you're dividing by 3, that means it's slowing down, right? So it's only happening every 3 months. So number 4 really lends itself to a good classwork based on what you just learned. So go ahead and do that. I am going to come back and show you the answers, and then I will talk it through. I'll put some notes on there as well. So if you're stuck, but think about what's happening in each problem as you go. You can also, again, write in the comments of your Canvas. You can't write in comments in YouTube, because I'll be checking those, but write in your comments of your Canvas submission when you put your notes in. That's one reason why I do collect up the notes. If you do that, then I get it right away. If you just write something on the paper itself, I won't see it as promptly. So, putting it in the comments, I get it in email, or just email me and we can talk about it in Zoom if you also want to do that, because this is a little bit tricky to think about and get them the right way around rather than exact opposite. Just to get you started off, in case you're stuck and not sure what to do, you are going to be writing exponential formulas. You have, or equations, you have the words this time, and you're working the other direction. But there is a linear thrown in there too, just to see if you can catch that. So be careful of that. But here's the first two. B of D equals 30 times 1.2D. Remember, we're adding the percent each time, right? Or to our 100% to make our base be 1.2 as a decimal. Here we're decreasing, so be aware of that. It's 100% minus 8% is the 0.92. You wouldn't want to put 0.08 in there. So see if we can continue on with that. So here are the remaining answers. So C, we started at 200, increase by 12%. Now that's pretty standard, but every 8 hours, that means it's 3 times in each day that's happening in a 24-hour day. So that's 3 times faster, right? So we're going to multiply. That's just even getting bigger faster. So think of that curve is going to go up even faster. And then this one was your trick one to see if you notice it's linear. It's 350 each day. It's not a percentage, so it's just linear. So watch for that. You'll have some of these in the paper homework too. A colony starts at 750 and doubles every time, so that's 200%. So that's just kind of straightforward. This one, the colony starts at 1 million and decreases with a half-life. So your base is going to be a half of 1,000 days. So it's per 1,000 days is what that of 1,000 days mean. So we're going to divide there because we're slowing it down. All right, so that's it for this video set. there'll be more on exponentials in your lesson, so look for those. This is part 2 for 4.1. Have a great day.